Welcome. So we're going to begin talking about inverse functions, and we're going to spend this first part of the lesson just reading through some definitions. Now, when I'm reading through these definitions, you might be thinking, I have no earthly idea what he's talking about, and that's fine, but we're just going to work through these definitions first, and then when we get into some examples, it will make a bit more sense. So don't freak out as I'm reading through these definitions if it doesn't make much sense. Okay, let's begin. A function has an inverse function if and only if it is a one-to-one function. If f is a one-to-one function, then its inverse is given by, and here we have the inverse of f of x is equal to y if f of y is equal to x, for x is an element of the range of f and y is an element of the domain of f. Alright, so at the moment, this probably doesn't make any sense at all, and that's fine. When we work through some examples, this will make more sense, and you'll be able to look back at these definitions, and you'll be like, oh yeah, that makes sense now. If we were to boil down everything that we're told here is just a nice little table. So, if we have a function, we have coordinates x and y. If we want to find the inverse function of it, that means the inverse, we're simply just going to swap the x and y positions. So we're simply swapping the positions of the x and y. And by doing that, what's now going to happen? Well, my domain of f, which remember consists of all my x values, well now, if my inverse has swapped the x and y position, my domain of f is now going to be the range of the inverse. And so too, my range of f is now going to be the domain of the inverse function. So again, if you're getting to the end of this part here and you're a bit confused, don't worry. Once we get into some examples, it will make a lot more sense. But that is just a broad introduction to what inverse functions are definitionally.